this is Himabindu from the Department of CSIT. So today in this video I would like to explain about the Turing machine. So how many types of Turing machines we have? So what are the various types of Turing machine we will discuss in this video. And here, how many types of Turing machines we have? Generally, we discussed about the designing of Turing machine. So it contains a tape. So infinite tape, infinite memory tape. So in that one, we have the finite control. So that finite control will move from left to right and right to left. So here this is the example of Turing machine tape. So this is a Turing machine tape, so which is a unlimited memory, infinite memory it is having. So in this one, the blank B, capital B represents a blank space, and these are the inputs what we are stimulating the strings in the given language. So these are the input values, and remaining or whatever there without input values, those are all tape in symbols or all blank symbols. That is nothing but blank symbols. So B represents blank symbol. So and we have finite automata control. So finite control. So that is nothing but FC. This finite control can indicates either it can move right, it can move left or right. So in direction, so it is moving based on the transition functions, based on the given language. So the transition can move from either left or right in the infinite tape. So here this finite control can, based on the transition, it can move to either this one or another state like this. So and with that left and right moves, we also have the read and write operations. So here read and write operations are nothing but, well, the finite control is on this place. So here the A is readed and this A is replaced with X. So that is nothing but the A is readed here and the writing of X in this place. Instead of A, we are writing the X. So that is nothing but we have two operations called read and write and we have the moves like left and right. This is the standardized. So we can say that it is the standardized Turing machine. So the standardized Turing machine, which is having this infinite length tape, and what are the operations, read and write operations are there, and we have the finite control. It can move either left or right. So based on the transition, we will move from left or right. And here this is the standardized Turing machine. And in the Church's hypothesis, we said that we have the Turing machine, which is many types of Turing machines, which is equivalent to the standardized Turing machine. So everything is computable in the Turing machine. That what we will represent it as a various Turing machine. So based on the functions, based on the computation models, we are designed the Turing machines various. So various Turing machines are there. The question they may ask like how many types of Turing machine or variants of Turing machine or modifications of Turing machine, and these are all same. These are all represent the same thing. That is nothing but variations of Turing machine. So how many types of Turing machines we have, and what are the variants in Turing machine or modifications for the standard Turing machine. So these are all same. These are all the same question which we can answer is, these are the Turing machine. How many types of Turing machine we have till now. And here this first one is a two-way infinite tape Turing machine. So we have a two-way. So see, in standardized Turing machine, if you saw this the infinite tape, in this one we are moving in this direction. So this moving either left or right, but we are moving in this direction. So that is nothing but we are only concentrating on the right hand side part of the Turing tape. So but when we say that two-way infinite tape, we can also have the both sides like left side and right side. So we will discuss. And multi-tape Turing machine. So here instead of one tape, infinite tape, we will take multiple tapes for the Turing machine. And non-deterministic Turing machine. So non-deterministic nothing but for one state we have the multiple choices. So we will discuss. And multi-dimensional tape Turing machine. So only we saw the two-dimensional just now, and we will saw the multi-dimensional how it is working. And multi-head Turing machine. So in this multi-head Turing machine, we have multiple heads. It can control the tape. And offline Turing machine and multiple track Turing machine. So these are the variants of a Turing machine or types of Turing machine or modifications of Turing machine. So in that one, first one is about the two-way infinite tape Turing machine. So two-way we just discussed in the standardized Turing machine, we just moving in the one direction. That is nothing but it is only the right direction we are replacing the values or whatever. So and we are not considering about the left hand side. So this two-way infinite tape Turing machine, which is also considering the left hand side part also, like this blank symbol and here also blank symbol. So this is a two-way infinite tape Turing machine. So infinite tape two-way infinite tape Turing machine is unbounded both directions. So there is no boundaries. So unbounded, unlimited infinite tape here. So in which direction, either left or right, in both direction we can unbound. We have the infinite tape in both direction, either in left hand side or right hand side. And two-way infinite tape Turing machine can be stimulated by one infinite tape Turing machine. So that is nothing but one standardized finite or one standardized Turing machine. We already discussed. So standardized Turing machine which is having only right hand side. So here this is a standardized. We can represent this one and we like this. So this header is moving in one direction. So here see, and it is starting from left to right. And here in the two-way infinite tape direction, infinite tape Turing machine. So here this either it can move this side or left side, or it can move right side. So this is the two-way infinite tape Turing machine. So which is can be equivalent to the standardized Turing machine. So if we consider the two ways and left and right of the infinite tape, so it is equivalent to the standardized Turing machine. Both are equivalent and same power it is having. And the second one, multi-tape Turing machine. So multi-tape Turing machine, which is it has a multiple tapes. So the name itself it is having the multiple tapes. So in standardized Turing machine only we have a single tape. So like this we have a single tape, but in multiple tapes we have the multiple tapes. So here we will design a multiple tapes here, and here also we will replace we will read the input values like this A, B, C to represent the multiple tapes. We can also have the same input in the different tapes, but for the making a variation we are taking the input values 3. And here if it is a first tape and this is the second tape and this is the third tape, and if the finite control, so finite control which is heading with the tape 3 here, and this tape 1, tape 2, it like this, and tape 2. And here coming to the transition, so here the coming to the transition, suppose here we represent the Q naught. So A comma B comma with the inputs A comma B comma C, we are replacing both values, three values with the, after reading we need to write something. So A is replaced with X, B is replaced with Y, and C is replaced with Z. So here Q naught comma, so which leads to Q1. So we'll make it as a other state and we will read it as a After reading, we'll write it as the values x, y, z. So here the finite control which is having the control over all the tapes. So here at a time we can get the transitions to the multiple tapes. So the multiple tape Turing machine is different from K-track Turing machine. So K-track Turing machine, that is nothing but multi-track Turing machine. We will discuss it later. And K-track Turing machine, but expressive power is same. So both are different. Here multiple tapes we are taking, and multi-tracking is nothing but, here we'll discuss. So here in the one, this is track 1, track 2 and track 3 and track 4. And if you get A, B, C, D. So here these are the values. At a time we will see both are different, but at a time the header is only one here. So FC 1. So header is pointing to the one row, and which is equivalent to the, which says Q1, and we are replacing with X, Y, Z and V. So here at a time we are replacing. So here this is the difference between the multiple tape Turing machine and this is a multi-track Turing machine. Both are different, but the power of the two machines which are equivalent to each other. And here the multi-tape Turing machine can be stimulated by single-tape Turing machine. So here which is equivalent, multi-tape Turing machine which is equivalent to the standard Turing machine. That is nothing but single-tape Turing machine. And this is about the second variation. And non-deterministic Turing machine. So a non-deterministic Turing machine has a single one-way infinite tape. So it has a single one way. So one way, we are saying that one way in the sense only. So suppose here B is there and A and remaining all blank symbol. So we are saying if it is not having the right left hand side, it is not having the blank symbol. So we can say that it is a one way infinite tape. So has a single one way infinite tape. And for a given state, the input symbol has at least one choice to move. Each choice has several choices of the path. So here we already know that what is meant by non-deterministic. What is meant by deterministic? So deterministic, that is nothing but DFA. If you observe that DFA, deterministic finite automata, for single state, so here the Q naught is the single state. So here the single state. So for this state in deterministic DFA, so what are the inputs we have? 0, 1. So 0, 1 is the input value. So for determinism, we have to give the path for each and every input what we are having. So here this is about the determinism. And coming to the NFA, so non-deterministic. So non-deterministic which is having the maybe a chance for the 0, we have a 2 paths for the 0 input. So multiple choices for the single input. So this is a non-determinism. So like that here non-determinism is also in the Turing machine is also having the multiple paths. So let me write what is the non-deterministic Turing machine with the transition, the instantaneous description. So with here the Q naught, here we'll take the Q naught. So here in the Q naught, if you have the 0, A as an input, and this is going to be replaced with X, and it is going to be moved to the right hand side. So this is going to one state, and for the same input, it is replacing with the Y, and it is moving to the direction left, and one more we will write. So for the same input, we will write Z, and we are moving to the right direction to the other state. So by seeing this diagram, what we can say that for the state Q naught, we are having the single input, what is nothing but A. We are reading this A in this path, we will get, whenever it is reaching the another state, it is replacing with x, and here also it is replacing with y. And this direction is also, one state, for one input it is going to the right direction, and for one input, the same input, it is going to the left direction. So this entire thing will say that it is nothing but non-determinism. So the non-deterministic Turing machine, which is equivalent to the deterministic Turing machine. So which is equivalent to the deterministic. So both and non-determinism or determinism, whatever it is, the Turing machine, which are all having the same power. Next one, multi-dimensional tape Turing machine. So multi-dimensional. So till now we have seen two-dimensional. That is nothing but, so rows and columns. So two-dimensional we have seen, and now we will see the multi-dimensional tape. So it has a multi-dimensional tape where the head can move in any direction, that is left, right, and up and down. So let me write this multi-dimensional. So multi-dimensional Turing machine. So here, if you take, this is a multi-dimensional. So a multi-dimensional means the n number of rows and n number of columns. So here in this one, and here I am taking the FC, that is nothing but finite control, which is the header which is pointing to this, and here A is there. Suppose A is there, and the multi-dimensional Turing machine can move in any direction. So if you observe standard Turing machine which is moving left or right. So when compared with the standardized Turing machine, the multi-dimensional which is having the directions up and down also. And let me write. So right, left it can move, and up, down. So we can also move this Turing machine head from up and down and left to right, left or right. So this is about the multi-dimensional tape Turing machine. So it is having the operation moves like left or right. It can move either left, right, up and down. So, and this multi-dimensional tape Turing machine can be stimulated by one-dimensional Turing machine. So both are equivalent. So stimulated by the one-dimensional Turing machine, that is nothing but only right hand side or left hand side, it is having the infinite length. So one dimensional. So it is equivalent to the one dimensional. So both multi-dimensional or one dimensional having the same power. And next one, multi-head Turing machine. So multi-head Turing machine contains two or more heads to read the symbols on the same tape. So here multi-head. So here multi-head represent FC. So finite control, which is having the same tape. So this tape, which is will take a two-way dimensional. So in this one, so A, B, C, and these remaining are all blank symbols. So blank symbols. So this multi-head. So multi-head nothing but, so here the finite automata, for this input it is having this A, and next it is having the multi-head. So here multi-head is there is nothing but, for A input it is one single head, it is B input it is going to the C. So this multiple head which is representing the same tape. In one step, all the heads sense the scanned symbols and move or right independently based on the head functionality. So here the A is A is going to be replaced with X, we need to replace, and B is replaced with Y, we need to read and write the Y, and Z instead of C we will write the Z. So both at a time in one step. So if you take multiple heads in one step, we can sense the scanned symbols and we will do the operations accordingly. So that is nothing but a multi-head Turing machine. and which is equivalent to the single head Turing machine. So here the Turing multi-head Turing machine is also equivalent to the single head or standardized Turing machine. An offline Turing machine. So an offline Turing machine has two tapes, so which are as follows. So we have in offline tapes, we have offline Turing machine, we have the two tapes. One is the one tape is read only in the sense the only tape. What is the, we have two tapes, so we'll represent the tape. So you will take both by two-way directional infinite tape. So here A is there, B is there, and we have a two tapes. So what it's the offline Turing machine which is having the two tapes. So we'll write the two tapes. So which is only read only. Here the first one is about the read only read. It contains the input value, and here the other is a read and write, initially blank. So and is initially blank, it is initially, and here we have the operations read and write, and in between we will write the finite control. So it can map to the A, and it can map here A, B, and we will replace it. Why? Because here the second tape which is having the write operation, but here in the first step it is only reading the A value. So A value it is reading, and here it will replace it with the operation based on the transition. So A is replaced with X and B is replaced with Y. And here, so here the two tapes we have, these are all called as the offline Turing machine. So offline Turing machine which has the two tapes. So in the two tapes, first one is about the read only. So read only tape. In this one we will just read the symbols on the tape. So the finite control which reads the input symbols. And here in the second tape, we have the two operations, read and write operations. So initially it is blank, and the finite control based on the transition, this finite control is moving either left or right based on the transition, and also it is writing the input symbols based on the transition. So this is about the offline Turing machine. So which is equivalent to the standardized Turing machine. And multiple track Turing machine. So a K-track Turing machine has K tracks. So here, so we'll write the tracks. So that is, instead of in tape, we are taking the tracks in the tape. And here, if so, suppose this is the track 1, track 2, and track 3 and track 4. So here the K track. So a K track Turing machine, for example, K greater than 0. So 0 greater than 0 we are writing. So here suppose the K value is 4, we will take the 4 tracks in the single tape. So 4 tracks we are taking. In that one we will represent the input symbols, read and write operations. So tracks and the one read and write head. So one read and write head is there. So here I will take FC, the finite control. So I will take the first one and read and write all of them on a one by one. So we will write here A, B, C, D. So one by one we are writing. So tracks, we have the 4 number of tracks we have, and for the single header, so it can manage, this header can manage a read and write operations on a multiple tracks. So K track Turing machine can be simulated by the single track Turing machine. So here they said that we have a read and write operation. So here this header can read the symbols and write the input. So here after reading, it is reading A input symbol, we will write the X, and B input symbol we will write the Y, and C input symbol we will write the Z, and D we will write the V. So read after reading A, B, C, D in a single time. So we will write the input symbols, and the read and write operation is performed in a single transition. So in the single transition, we performed the transition function, and here after reading and writing we have to move either left or right. So here moving to the left or right based on the transition. Suppose it is moving to the left hand side, it has to move here, and if it is suppose here for this operation it is having to move to the right hand side, this remaining all are blank symbols. So here blank symbols. So empty cells which are blank symbols. And here if we are moving to the right direction, we need to move this header to this direction here. And here we will replace these values based on the transition. We have to replace the values. So here like this we have to move to the left or right direction for the single header for the multiple tracks. So multiple track Turing machine. So this is about the multiple track Turing machine, and these are the references. So here what are the Turing machine variations? So two-way infinite tape Turing machine, we have a 2 infinite tape length. Either it can move either left or rightwards. And multi-tape Turing machine. So multi-tape Turing machine which is having the multiple tapes, and the header it is also controlling multiple tapes at a time. And non-deterministic. So for one state we are having the single input. So single input which is having the multiple choices to the other states. So, and for that states also it can move either left or right. And multi-dimensional. So multi-dimensional which is having the moves like left along with the left and right, we have up and down. So multi-dimensional in the sense multiple number of rows and columns we have in the single tape. And multi-head Turing machine which can control multiple heads which can control the single tape. So for the single tape it is having the multiple heads. So this heads can control the Turing machine at the same time for different inputs. And offline Turing machine which has the two types of tapes. One is read only, and another one is read and write operations. So based on the transition functions we can replace in the second tape, and in the first tape we need to write only operation is performed in the first tape. So that is nothing but offline Turing machine. And multiple track Turing machine which is having the multiple tracks in a single tape. So multiple tracks we will write one by one input in the tracks, and at a time the single header can control the multiple tracks, and the read and write operation is performed, and either it can move left or right direction. So these are all about the Turing machine variations. So this is about the Turing machine variations. That's all. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.